So actually, the semester is going to end in a couple of weeks, so we'll not get enough time to demonstrate this in the class. So actually, this is the third cycle of experiments, which are actually the SPICE simulations. And here we are using a software called KCAD. And these are the list of experiments, 6 experiments we have. So in this video I will demonstrate the first one. It's RC integrator, and in the second video I will demonstrate this stable multivibrator. So you people are advised to do all these experiments in the KCAD and submit it to me. Okay, so let's start. Actually this software KCAD is actually a free software, so you can download it freely from this website kcadpcb.org. So in the download section you will have versions for Ubuntu, Mac, Windows, everything, so you can go for it and download. These are a few hundreds of MBs. I think up to 1 GB. Okay, so let's do the first experiment, RC integrator circuit. So I am launching this KCAD. So this is the window, and we can create a new project named so let's be RC underscore integrator. Let's save this in the KCAD directory. So after creating the project you will get two files, PCB and schematic. Here we are actually doing the simulation of the circuit. So first of all we have to draw the circuit, and that's done in this schematic. So the file is with an extension SCH. So this is schematic file, and this is the PCB file, and we are not actually trying to design the PCB right now. So let's open this schematic. So right now this is a blank page, so you can zoom in and zoom out like this. So here you have to draw your circuit, and then we can do a number of checks here, and then after that we can simulate the circuit what you have drawn using this simulator here. Okay, so let's first do the RC integrator. It's a very simple circuit, you have one capacitor and a resistor. So this right side panel have all those components. So this is just an arrow. You have see, using this you are actually placing the components. This is power ports, ground, as well as VCC you will get from the wire, bus, so many things. So let's first click on this. You will let know what these things are. So click on that, and then your arrow appears as a pencil here. So click on the page, so it loads a library, and from this we actually are doing this SPICE simulation. So search for PSpice library. Yeah, PSpice. So you need just one capacitor and a resistor. So let's first place the capacitor. Double click on the capacitor, so your capacitor is right now with your arrow. So place it somewhere, click on that place. Okay, next you need click on anyway. See, what you are doing here is clicking on this sheet. So this comes, and next you have to search for resistor from the PSpice library. So resistor R, double click. So this I can change the orientation, right click, orientation, rotate clockwise. So now it's like this. And now what else I need? I need a source. So again go to PSpice, you will have the spice source there. PSpice vSource, double click, and I'm placing the source here. Then I need ground. So again go to vSpice, this ground, spice ground. So you can double click on this, or you can use this place power port, click on the symbol. So PSpice 0, double click, I'm placing it here. Okay, so now I have this pencil. So I now need to connect all these components together. So I will select wire, place wire, click here, so it will come along with it. Next click here, click, connect this and this, connect this with the ground. So that's it, it completes the integrator. So next you need to do is choose this. Okay, then here you have a number of analysis tools. So this one is annotate the schematic symbols. This you have to do first, because right now you have one resistor and capacitor, but they have not been named. So here you have a question mark, or C, voltage source is not named, again a question mark. So first click on this and click annotate. See, now the question mark has been changed to R1, C1 and V1. Suppose you had a second resistor, then that would have been named R2. Okay, so that's the purpose of this tool, annotate. Then you have a second tool called perform electric load checks. It's called ERC. So click on that and run ERC. So you have one warning. Warning is okay. You will have 0 errors. This will indicate if there is some disconnections or unconnected pins or anything like that. So right now we don't have, so it's okay. One warning is actually that pin 1 of the power input is connected to ground 0, say. So that's fine. Close. So this is connected to ground. That's a problem. That's not a problem actually. This is a driving pin, it's connected to ground, but here it's not a problem because the driving pin 1 has been connected properly. Okay, so this completes the schematic. Now you have to give values for your components. Okay, so for this resistor the value is not defined right now, so let's give 1 kilo ohm. So you just need to type 1k. Ohm is not needed, 1k. That 1k appears here. So let this be capacitance value is say 10 microfarad we need, so 10 mu f, and instead of mu we have u, so you just need to type 10 u. It will be interpreted as 10 microfarad because this is a capacitor. Okay, so 10 u, 1k. And now what is the voltage source here? This is not a DC source, so you have to edit the source. So we are actually applying a square wave at the input of the integrator. So this needs to be a square wave. So click OK. I will do this once again. So this is supposed to be a square wave source, square wave voltage source, says 5 volt. Okay, so double click on this, then this value, okay, you click on this edit spice model, and so it's supposed to be a square wave, so sub square wave is coming under the category pulses. So initial value we can give 0 volt, and it's a pulse with peak value 5, so here it's 5 volt. So initial value 0, then 5 volt, and delay time means when they should start. Say they should start with, say, 10 milliseconds, and rise time we can give 1 microsecond. Micro is on mu f, microsecond is mu s, so mu is typed as u. Fall time 1 microsecond. Pulse width, so we are supposed to make a square wave, so pulse width means the on period of the square wave. It can be on millisecond, so the we need 1 millisecond of time also, so that means the period should be 2 milliseconds. It's voltage, not current, so this is enough. So initial value, pulse value means peak value is 5 volt, initial value is 0 volt, delay time 10 milliseconds. So after 10 milliseconds this waveform starts. Rise time 1 microsecond, fall time 1 microsecond, pulse width on time duration is 1 millisecond, and off time duration and is supposed to be 1 millisecond, so all off plus on is the period, it's 2 millisecond. Okay, click okay. So it completes the simulation setup. Now in the tools we have the simulator. Now before running the simulation, click on the settings. You are actually setting here what region you are simulating or what you are going to observe. So here I'll click on the transient, means I am going to observe the transient response. So our actual pulse will start after 10 milliseconds. So my final time, see, I am observing a duration of say 200 milliseconds. Initial value is 0, so from the beginning is, and time steps, each time step can be say some 1 millisecond maybe. If you give, okay, I will explain what this is later. So click OK. Now you can run the simulation. So the simulation has been completed. You have this many raw data created. Now we have to see what signals have been generated. So for that, click on the probe. So these are just like CRO or DSO probes. So at this point I want to observe the waveform, so I click there, and this is the input waveform. I click there also. Then I go to again simulator. Let's see what waveforms are there. So clearly the waveform starts after 10 milliseconds. Your input starts after 10 milliseconds. You are observing a window of 0 to 200 milliseconds because that was your settings in the transient. So in the transient we have set the observation window as from 0 milliseconds up to 200 milliseconds we are observing, and as per the specification of our input waveform, it starts only after 10 milliseconds. So it starts after 10 milliseconds. Okay, and now I can actually zoom in this signal for a small duration. Okay, so the signal will look like this. So this is the input signal. Input signal is a square wave, pulse 5 volt, pulse width, what is this, 10 milliseconds, 11 milliseconds, so 1 millisecond wide on time, and 2 milliseconds is the uh, total time period of the signal. Okay, so off time 1 millisecond, on time 1 millisecond, and the magnitude is 5 volt and 0 volt. Okay, so this red color is the output. So this output, see the red color, output slowly builds up because these are the transient regions, initial turbulences, and here it settles. So let us see the nature of this output waveform when it settles. So I can observe a small window here. See, so input is green, square wave 0 5, and your output is a small triangular wave. Okay, so it's a perfect triangular wave. I can even zoom in to see what it is. Yes, it's a triangular wave. So it's working as an integrator. Okay, now here you have another tool called tune the component values. I'll click on this. Now I will click on the capacitor. Now again I will go back to the simulator. Now here you can see a new space where your C1 capacitance value C1 can be changed. Now if I increase C1, there will be a change reflected in the output. It's not visible. I can increase this. It's not clearly visible. So if I decrease this, okay, you can observe the change. If I decrease the capacitance value, it's like this. If I increase, I get better integration but small waveforms. If I decrease this capacitance value, if I decrease, it will be like this. So it can be better observed if you have a larger time period signal. So let's just close this, press the escape button to now click on this, edit the spice model. So here let's give pulse width of 10 milliseconds and duration 20 milliseconds. Okay, okay, tools, simulator, settings, transient, time step 1 milliseconds, final time what we have given earlier was 200. Let's give 200 milliseconds and 100 milliseconds as the initial time. Earlier we haven't given anything here, so it started from the 0th second. So click OK, run the simulation, go to the prompt, this input. Now again tools, simulator, you'll see. Okay, so here it can be better also. Okay, now we'll take this tuner, click on this, so that value we can change. So we can go to simulator. Now we have the capacitor. See, I increase the capacitance value so it becomes a better and better integrator. See, this becomes linear. So if I decrease the capacitance value, it's not that good an integrator, but your peak to peak value of the output signal increases. See, actually this is an exponential charging, but we stops here. Okay, so we get a curved output signal. So if we increase the capacitance value, the charging and discharging happens for a very small duration. So even though this is a long exponential, this appears almost straight during this region. Okay, so this completes the integrator